Okay, today we're going to talk a little bit about polynomial applications, so like what you would do with a polynomial. So make sure you have today's date. For some of you it might be 4-5, for some of you it might be 4-6, so make sure you have the correct date here, please. Polynomial applications, basically just like different shapes we want to deal with. So like, for one example, let's say we had a rectangle. Well, the area of a rectangle is just length times width. And in this example, the area is going to equal 6, the length, times the width of 2, and the area of this is going to be 12. Hence, the 12 dots here. Right? So, that's basically what we're looking for. So we want to just understand what we would do if area was not just this simple. I mean, you're really just multiplying length times width. So what if you had a polynomial type of area like the one shown below? So let's just grab this. So here we have 2x, which is 2x to the first, but just 2x if you like, right? And we have 2x, and we're multiplying it by 3x squared, because we're going to do area equals, right, length times width. Well, we know the area is equal to the length times the width, and the length is 3x squared. We know the width here is 2x. So when we take those and multiply them, it's just like any problem that we've done. It's 6x to the third. That's the area of this shape. Making sense? So that's what we're looking for, just multiplying the base times the height. It can get more complicated as time goes on, but this is the general idea. Is we're trying to find the area or the perimeter. So we're either going to add up the sides for perimeter, which we haven't talked about yet, or we'll just multiply, right, to get the area. So what if we get to some a little bit more complicated problems? Let's try some different ones. How about what's the area of this triangle? Well, what's the area of any triangle? Like, do you know the formula for the area of a triangle? I just put this little t here to show that it's the area of a triangle, not the area of anything else. So area of a triangle is, hopefully you remember it, 1/2 base times height. So the question is now, what's the base of this triangle? Well, the base of this triangle is simply x. The 1/2 doesn't change. We have to multiply that by the height. So the area of this triangle, the height of this triangle is x minus 2. We need to multiply everything by x minus 2. We can't just multiply by the x and then subtract 2. We want to multiply by parentheses x minus 2. This is the whole thing. So now we're going to multiply both of these, right? So actually what you end up getting is the area is equal to 1/2 times, and now again this is going to be two things. It's going to be x squared minus 2x. So we're going to have to think about that as a half. So the area is 1/2 x squared minus, well, 1/2 of 2 is 1, so it's just going to be simply x. So that's the area, okay? But what if x was 3 feet? So how would we figure out the area? Well, if x was 3 feet, just a new color, this would be now 3, and this would now be 3 minus 2, which is 1. So the area would equal 1/2 base times height, so it'd be 3 over 2. So we know it would be 3 over 2 if that was the case. Now how does this match up to what we wrote here? If x is equal to 3, well, the area would equal 1/2 times 3 squared minus 3. So that's going to be 1/2 times 9 minus 3. So getting a little complicated here, but let's just work on this purple part for a moment. Let's get these things out of our way. So, we've got 9 over 2 minus, I guess that'd be 6 over 2. 3 over 3 is 6 over 2. That'd give us an answer of 3 over 2. So you'll notice that you get the same answer with this equation, because this is the equation for the area with any given x. Doesn't necessarily make it simpler. I think it's easier to do it this way, right here, but it is important to see how it connects at least. This one's actually a slightly easier, except the only tricky part is that you have to write it out yourself. They didn't give you the labels. So if the rectangle has a length, right here, length, and a width here, the length is 2 feet longer than its width. Well, the length is then the width plus 2, right? Wouldn't you agree? 2 feet in addition to the width. So that's really the length. We don't really want this. We want one variable. Anytime we can get it into one variable, it's better. Take a second to think about that. Ask questions if you have them. Now we want to do the area. Well, area is equal to length times width in either order. And then we can simply distribute. And we have that that's the area of this rectangle. Okay? So that's where we're going with the applications here. I don't think we have much more. There might be a little bit more complicated type that we'll go over quickly. You might have to do something along the lines of this. Find the area of this region right here. Okay, so if you're going to find the region of this is kind of like a donut, right? Well, if you're going to find the area of that region, what you're going to want to do is find the area of all of this. So let's say this was x plus 2 times x plus 7. And let's say this area was just x times x plus 1. Well, what you're going to want to do is find this red area of the red, and then you're going to want to find this blue area and subtract them. And that will give you the shaded in area, which I guess is actually just the red area. Not the best way. The area of the red equation, sorry, minus the area of the blue equations will give you this whole thing right here. We'll highlight it. Okay. So that's a donut. It's like finding the area of the whole donut and then subtracting out the donut hole to find out what the area or the actual amount of donut you're having, right? If you're eating a donut that doesn't have a donut hole, it's going to have more calories, right? It's going to have more fat and things like that. So we're talking about now taking that donut hole out and just having the area of this. So we'll have problems like that. You're going to subtract them. You'll find this area, you'll find this area, and you'll subtract the two. Okay, so good luck with that. Shouldn't be too bad. Pretty short lesson. Excellent. We'll catch up soon.